on Health Channel. This video is called I Got Younger. So we're going to discuss this chart today and go deep into it. And so this is from 2006 to 2024. So I was 43 in 2006 and 61 this year. And you can see, just every year you go up a year. And this red line is what's called my biological age. So, at 43, I was biologically 40. And then this year, 61, but biologically 43. Same age, as then. So, the question, I guess, like how do I know my biological, thing, so, that's what I look like. This picture was taken last week, very skinny, and, it's like, I don't know, cancer or like, whatever. But this is what I looked like, I was like flexing, and we have a tonal. This is the tonal, so it's, and you can see here it says your strength score is higher than 99% of male tonal members. So it's around 1,200. And, if I had cancer, like there's no way like my strength would be like that high. But, and then another thing is, this is what I weighed this morning, 174.8. When I was a senior in high school at 18, that was 1981, I weighed 175. So, could I tell from my weight what my biological age is? No, because this is my weight over the last, since 2008, basically. And you can see it bounces up and down and up and down. And then this morning I was 175, right? There's the 180 line and bouncing. So that's not, my biological age, although it's, it's like, it would be, it's partly that, but, when you're, let's see that picture again, like up here, I weigh almost 200. That's the highest I've weighed. And, my gut would be like 3 inches bigger. And that's definitely, I'd be older. But like I said, that's not a good measure of biological age. So what it is, based on my biological age on blood tests. And, here's another way to do it. They say your VO2 max. So I have a Fitbit, right? There's a Fitbit I'm wearing. And every morning it estimates my, it says, what does it say? Your estimate of 52 to 56 is excellent for your, my VO2 max. So it's estimating it based on my, like they give you what it is. So, that would definitely suggest I'm, biologically younger. And, but, that number doesn't change over time much. It's been the same for, a bunch of years. So again, that's not going to tell me biological age, but does, suggest I am a bit younger. So my muscles and my strength and that. But like I said, it's based on blood tests. And This is the blood test I've been getting every year since I was 43. It's called the male panel blood test by Life Extension. Costs $224. This is a spring sale. Normally it's 300. And you can see chemistry count, and I'll show you my spreadsheet, but basically it's a lot of different things. A lot of different things. I think there's 42 metrics in it. And like I said, what they do is once you get your blood test, they send you a PDF with the results. You can see my glucose was 90, which you'll see in a minute is higher, and I'll explain why. But they send you a PDF, and I copy that PDF into a spreadsheet. And you can see from 2006, glucose was 83. And if I scroll down, you see that 90. That 90 is what you saw in the PDF. So I just copy the numbers. And, you can see there's a whole bunch of them, right? Like we go over here. I mean, there's like, I counted like 42 or 43 of them. And like I say, I've been getting them, these tests, since 2006 all the way up to 2024. Sometimes I go and get a physical. That's why there might be 2 and 210, because I went to a doctor and they did a blood test. But the life extension one is always in May. So this is the month, May. And so for 18 years, I've been getting blood tests in the spring, May, sometimes it bleeds into June. And it's got like 42 or 43 metrics. And up until the last couple of years, it's like, I don't know, what am I going to use that for? Well, one of the things I have with it that's useful, so the reason I put it in a spreadsheet so I can compute the median. What's my median number over that age? So you see my median glucose is 85. So this 90 was high. And why was it high? So I'll just jump into that. I was taking my 18-year-old daughter to high school, and at 8 o'clock, and then I think it was around 9 o'clock in the morning I got that blood test. Normally I go at 7 o'clock. So I get out of bed at 6:30, drive to the lab, get the blood test taken. And I've noticed, because I used to wear a CGM, a continuous glucose monitor, not because I have diabetes, I like data. And I could see that when I got up, boom, my glucose would jump, even though I didn't eat anything. And then within 2 hours, it would jump even more. So basically, this glucose of 90 is just because I got it taken at 9 a.m. instead of 7 a.m. So normally I'm at 85 at 7 a.m., but waited another 2 hours and boom, it jumped up to 90. So it's interesting how the body works. But anyways, you can see I got these 42 numbers, and, I've used it for different things, but it's not that quite useful. It's just nice, good data to have. And, but a couple years ago, I'm a consultant, and one of my clients is a longevity clinic in Hawaii. And so I read a lot of longevity books and, blah, blah, blah. And then so I came across this spreadsheet, which is based on this study. There was a study done in 2018, and the study, let's scroll up to the top here. I was reading it yesterday. I'm going to explain the study in this video here. Here we go. Okay, an epigenetic biomarker of aging for lifespan. And basically, it's your biological age. And it's a 2018 paper. And one of the authors is Steve Horvath. And if you've heard of the Horvath clock, this is basically taking what this guy came up with and then getting it from blood tests like this. And what they did in this paper is they took, and I'll show down here, what they did was they said they went to some database called this study, NAHAND, whatever, and they got 42 biomarkers, and they figured out which of those, so they reduced it to 9, that could predict biological age the best. And so these are the 9 they did: albumin, creatine, glucose, protein, and all these, right? These are 9, and then you put your age in here, okay? And so what they do is you put your numbers. So this is my numbers from 2024. So if we go here, you can see glucose is 90, and what else is in here? Creatine is 0.92. Let's see, did I copy it in right? Yeah, 0.92. Okay, so that's all I did. I just copied it from my spreadsheet there, and then I put the numbers in here, and I put my age, and it computes an estimated age of 43. And so there you have it, 43, a little bit over 43. And what's interesting, like I sent the mail to friends, is that if you go to 2023, the number's 44. So let's go to the summary of this spreadsheet and just show you here the number. I just copied these numbers, right? They come from, these tabs, right? So the 2024 number, this is like a couple weeks ago, I measured 43 and a half, let's say. A year before that, I measured 44 and a half. So I got 1 year older, like this, doink, but I got 1 year younger biologically. So this is why, the title of this is I got younger. I did. I got 1 year younger. And I'll show you something else interesting. So I told you I got like a 90 glucose because I took it at 9 a.m. Let's say I took it at 7 a.m. and I got my normal median number. Watch this. So it goes from 43. I'm going to put in 85. Oops. Let's see here. 80. Why is not working? Well, when I put in 85, oh, that's why, because it's not tied now. I don't know why I can't. It's dead right now. Strange. I can't edit the thing. When I put in 85, this dropped down to 42. So it wasn't just 1 year younger, it was 2 years younger. So I'm kind of bummed because I only get this blood test once a year. And I would have liked to, say, hey, I got 2 years younger. I went up 1 age biologically, chronologically, but I got 2 years younger. And so I'll tell you one of the reasons I like this paper. So what they did was, how did they pick the 9, right? How did they pick the 9 out of the 42? Well, what they did was they used this methylation, that was the Horvath clock, and they use, basically the way it works is like in our DNA, this is what I've read. I'm not a doctor, but in our DNA, like, the genes get turned on and turned off. Turning on, I think, is acylated, or I can't remember to pronounce it, but turning off the genes uses methylation, let's see if I can get the word here. Let's find methylation. That's the word, okay? So basically when genes get turned off, it's methylation. And the Horvath clock counts methylation in your body, but it's an invasive, it's like an expensive test, and how to test methylation in our bodies. And it's not like a blood test, right? You just go in the blood test, and I use my left arm. I have a big old vein right here, and then, the nurse puts in the needle, and then they just draw like how many vials of blood, little tubes of blood. That's simple to do, and that's how I've gotten, my, how many years of a blood test, right? Like it's just, getting a standard blood test. And like I'm saying, that study identified 9 specific ones that then help you compute your biological age, right? They're based on it. There's formulas inside the spreadsheet that just generate that age. wonder if I can put in 85 now. I don't know. I guess not. Very strange why I can't edit it. But but I'll tell you the reason I like this study, though. I said it was 2018, had the many authors, including the author who came up with the Horvath clock, and they realized, hey, if we're going to give this test to everybody, everybody's not going to get a methylation gene test, too expensive. You just get these 9 metrics out of a blood test, and what they did was they used AI to to figure out the 9. And what I really like about this paper is so these are the 9. So they came up with the 9. That's the same 9 in the spreadsheet. I got this, I don't know, can't remember where I got it, but it's based on this paper. So these are the 9 that they identified were the most predictive of biological age. And then what's interesting is they correlated those 9 with all these diseases. That's one thing they correlated it with. They said if you were 1 age biologically older, right? I'm 1 year biological, but let's say here I went up, a year or 3 years, whatever. They're saying if you go up a year, the idea that that you could die of anything, goes up by 9%. You get 9% older. Cancer, 7%, more likely you get. Alzheimer's, 4%. Diabetes, 20%. You know what I mean? So basically, all these diseases of aging, by biologically getting, 1 year older, like that, they're saying, that you just raised your likelihood of getting any of these diseases or just flat out dying. So they just showed this biological age is quite correlated to health. It's like, and the other thing they correlated it with, what I found really persuasive, is, come on down here, this picture here. What they did was they correlated, again, 1 year older of that number, and they said, what would it do to aging of all the different tissues? So, like, let's see, they found breast, epidermis, colon, heart, kidney, liver, lungs, survival, and basically they showed that 1 year jump makes your aging of your organs and all over the brain and everywhere also older, like testing the methylation, right? So basically, what I think they did with this paper is they really verified these 9 metrics are really useful for calculating your biological age. And I will just say one more thing, what I believe about what the metrics mean. It's your sort of metabolic system, okay? So let's say I was a car. This is not about my tires or the body or the windshield wipers or the trunk or any of that. It's about the engine. And let's say gas cars are more easy than electric cars. Electric cars are simple. They don't have any fluids, whatever. But let's say we're I was a gas car. This is about the engine, the pistons, the oil, the air filter, the oil filter, all that kind of stuff, right? So it's about how well is the car running, okay? Not about the transmission to the wheels, to all the different stuff. It's just the engine. So, you could take a really healthy engine, like that got into a car accident, and let's say the engine survived really well, but all the doors were jammed, broken and bent and scratched and whatever, and the windshield, was cracked and whatever, and it looks like a junk, but the engine is still good. You could use that, put it in another, So basically, that's what this is about, is the metabolic system. So glucose is like the gasoline we put into the car. that has the engine. C-reactive protein is about the heart which pumps around this blood with glucose. If it gets inflamed, this number will go up, so this number needs to be low. Albumin is, I think, and creatine, these are liver numbers, and the liver is important for getting out toxins and storing some glucose, so it's all part of this metabolic system. And some of these over here you could see are immune numbers. White blood cells, red cell, immune cell volume, lymphocytes. These are immune numbers. And the immune system is like, again, keeping the engine going, you know what I mean? Because sometimes your energy is used for running and doing this video or whatever. Well, if we get invaded by a pathogen, then the body goes screech, takes that energy used for running or doing a video, sticks us in bed, and so the immune system then inflames and eats the damn pathogen, and then we get better. We get out of bed and we can get running again. So it's basically a different use of the energy that this motor is producing. We can use it to run, or we can use it to heal, with the immune system. So that's why the immune numbers are important, because basically if those immune numbers are off, but all the other numbers are good, you're not going to do well, because, when you get any kind of pathogen in you and that immune system ain't working well, then it's going to harm the rest of the engine. So that immune is not in the car. The car doesn't have self-healing properties. Our immune system is a self-healing property. So anyway, so this is what I found, really interesting, is that the numbers that these weren't hand-picked numbers. These were using machine learning. And basically, they just ran AI on this. That's what this paper talks about, to get from 42 to 9, right? To get 42 down to 9. This was a machine figuring this out. This wasn't humans picking it. And funny enough, the machine picked basically our metabolic system, our engine. And I'll say one more thing, that the metabolic system, I read Peter Attia's, one of the many, many books I read, but I read Peter Attia's book called Outlive or something like that. And he had all these authors have their own model of, aging and whatever. And anyway, his was basically, picture you got the metabolic system at the bottom, and the health of that is important, because once it starts getting unhealthy, when we get older, you get what he called the 4 horsemen: cancer, heart disease, Alzheimer's, dementia, and diabetes, metabolic disorder. And those are the 4 horsemen. And back to my biological age, so you can see how it's computed off those 9 metrics. This is a really interesting story, and I'll end the video with this. Okay, I'm 43 when I started these blood tests, right? I got 18 years of them. For the first 3 years of taking the blood tests, what's interesting is the red line just tracks the blue line, maybe 2 to 3 year difference, okay? And what that is me not paying attention to health things, what I ate. I was exercising just because I'm a former athlete, and I like exercise, but I wasn't really paying attention to what I ate. I was eating, some of the sad diet, the American pizzas and like whatever, right? And and in sleep, I wasn't, really paying close attention to, so I just living my life, and living my life, there I was, my body was tracking 2 years younger than my chronological age. So, people that say to me, oh, you're just healthy because of your DNA and whatever, and that's why you're so healthy at 61. I'll say, yeah, for these first 3 years when I wasn't paying attention. And then what happens after 3 years is right there, I start paying attention to food, so the diet, my exercise, and my sleep. I started paying attention to it and iterating and improving, you know, like what's good for my diet, what's not, what kind of exercise is good, what kind of sleep is good. And that's what this is all about up until this point. But what's interesting is, so once I started paying attention to my food and you know, exercise and sleep, you could see what happened to this number. It was like ticking under 43. So this is 43, this number here, under, right up until from 2016 to 2017. Sometime during that year, all my efforts of diet, exercise, and sleep, my body was like, well, thank you for doing that, but I can't hang on to 43 forever. So I'm going to jump up now to 48, or I don't know what this number is, right? But it's older. If this is 43, that's probably 47. So for these 3 years here, that's my body trying to stay low, but you know, kind of like hanging on now to 45 to 46. You know, I don't know, maybe 47, something like that, right? Biologically. And what's interesting is this drop right here, and that's on the picture for this video. I dropped from whatever this number is, let's call it 46, all the way down to like 39, like 39 point something. And that was a precipitous drop. And then I jumped back up, but then I kind of stayed at, you know, and I came all the way back to 43 where I started, right? And so what I'm going to do, another video, I'm going to describe what I did. I made another change. Remember I said I was paying attention to diet, exercise, and sleep to get to this point, you know, from this point to this point. I was paying attention to those things. And I will say, what is this point here? 2020, spring of 2020. Remember what that was? That was the beginning of the COVID lockdowns. This was the darkest days of COVID land, where we're like, virus from China, and you know, the government's locking it down, and like, you know, there was all this propaganda of fear coming through the media, and like we're all stuck in our homes, and the poor kids are like now Zooming for school and all that. And so while everybody else was sitting on their couch, you know, getting fatter, I got a hell of a lot younger. Stay tuned. Next video, I'll describe why that is. I think it's a fascinating story. Anyway, thanks for listening. And next week, we'll explain that drop. Stay healthy.